Alright guys, here is homework number 3. We're dealing with transformation. So if you look over here, this is any function, I call it f, right? The a on the outside is going to affect the y. The x minus h, because it's inside with the x, and the x-axis is going left and right, that's what moves everything left or right. But the thing to remember with the inside, it is always the opposite operation. Just because you're trying to see what makes this inside factor x minus h equal to 0, and if you put a positive h in there, that's what makes it go to 0. So that's why we want an opposite operation. And then the plus k is on the outside, so that's what moves everything up or down, and the outside is the same sign, that if it is a plus 3, we'll move it up 3. If it's a minus 3, we'll move it down 3, whatever the function is. So you can go through vertical transformations. The k is on the outside. Horizontal, right? The h is inside with the x. Think alphabetically as well. Another name for f of x is y. So y comes after x, k comes after h. Same thing, okay? So x is on the inside, the h is going to go with the x all the time. So be careful with the x minus h. It is moving to the right h units. X plus h moves it to the left h units. The vertical translation means that if you have a function with an a on the outside, if a is bigger than 1, so let's say 2, 3, 4, it is going to be a skinnier graph. If a is between 0 and 1, the graph is going to get fatter and fatter and fatter. So then the direction of the graph, if a is positive, the graph is going to originally point up. If the a is negative, the graph will point down. Now I just picked a parabola as an example, but it could be a line, it could be a cube root, it could be any one of these parent functions that we talked about earlier. Okay, so this is the chart. If you turn your head sideways, right? These are going to be the parent functions, and then this is going to be the table of values that we're starting with. This is what the original graphs look like. Okay, the ones down here, this is the parent functions, right, with all the transformations built in. So the a is on the outside, that opens skinnier or fatter, the h moves it left or right, and the k moves it up or down. Okay, so we're going to be using this sheet a lot to start the problems over here. So let's get started with problem number 1. Because I see those bars around the x minus 2, my parent function is going to be the most simplest form is y equals absolute value of x. So then I'm going to switch over here and see absolute value of x, and I'm going to use these table of values, and the original graph is going to be the straight lines on both sides. So I can come back over here and say my original table of values is x comma y, and I'm just copying them from my chart. Ooh, that's not right though. That should be a 0. Now that's right. Okay, so then my table of values that I'm transforming, it looks like inside with the x is a x minus 2. I know inside x minus, look up here, x minus h, I'm actually moving to the right h units. So that means that I'm adding 2 to all of my x's. So I'm going to put an x plus 2 up there, and then I'm going to add 2 to all my original x values. So 2 minus 1, I say minus because plus a minus, right? I get 1. 2 plus 0 is 2, and 2 plus 1 is 3. Notice I don't even care what the y's are right now. I'm just dealing with the x's. I'm moving all the x's 2 to the right. The next one. Because we have this plus 1 on the outside deals with the y values. So if I move the screen back up, I see here's my y on the outside, right? Plus k means we're moving everything up k units. In this case, my k is 1. So I'm going to go and say my y are going to be added 1. So just this column on the right, we're going to add 1. 1 plus 1 is 2, 0 plus 1 is 1, 1 plus 1 is 2 again. So then what I have to do is graph each of these ordered pairs to come up with my final answer. So 1 comma 2 is right there, 2 comma 1, and 3 comma 2. Okay, now remember from my parent function over here, It is a straight line on both sides. It's a V that it makes. So when you go and you connect the dots, you better make the same V straight line down this way and straight line up that way. So there's that side, and there's that side. Okay, and that's your final graph. Now, to check that you're doing it right, you can use Desmos again. So I went to desmos.com/calculator, and I'm going to plug in my function. My parent function first, so f of x equals, and then absolute value. Let's see if I can bring up the screen. Absolute value is right down here. Okay, absolute value, I just clicked it, and then I'm going to make it x. Okay, and the next one, I'm going to say f of x equals, and the problem was absolute value of x, I forgot already. What was the problem? X minus 2 plus 1. Okay, so let's come back over here. X minus 2, and then on the outside was a plus 1. So I have both of my parent function and the transform function, and I'm going to bring over here and it graphs it for you. So if you notice the vertex that started at 0, 0, and then we moved it over here to 2, 1, right? Didn't we move the whole graph over 2 to the right and up 1? Okay, over 2 to the right and up 1. So the vertex, that starting point, is now at 2, 1. So you can literally see that the red line, every point got moved over and up 1. Pretty cool that you can check it, right? I thought so. I thought so. All right, let's try the next one. So now I see my parent function happens to be an x squared because I see a squared up in the exponent. So I'm going to go back here. X squared is right there. So I'm going to take these table of values and I'm going to write them down. So my original table of values for x, y equals x squared, basic, is -1, 0, 1, 1, 0, 1. So how am I getting this? I'm taking the -1, I'm putting it into the squared function, and I get a positive 1. I take 0, put it into the squared, right, and I get a 0. I plug in a 1, 1 squared is still 1. So that's where the original table of values comes from. Now we need to make the new table of values. So since I look inside with the x, see how this x down in problem 3 has x minus 2? It's inside. The next one down here, it has x plus 3. It's inside parentheses. This one was x minus 2. It was inside the absolute value. This one doesn't have anything inside. There's no parentheses. So that means my x stays exactly the same. I don't have to change it. I'm going to keep it -1, 0, and 1. And then the outside, we're multiplying by 2 and we're subtracting 1. So the outside is always going to be the y's, the a there, and then the plus k there. So those are plus k minus k. Okay, whatever the sign is, you're going to keep it the same. So if the x squared is considered y, because y equals x squared, I know I'm going to multiply all the y's by 2, and then I'm going to subtract 1. So we're making the graph skinnier, and then we're moving it down 1. So once again, you multiply first, order of operations, and then subtract 1. You're only dealing it with the y's on this original table of values. So 1 times 2 is 2, 2 minus 1 is 1. Multiply by 2 and subtract 1. Multiply by 2, subtract 1. So now we're going to plot these ordered pairs on our graph. -1, 1, 0, -1, and 1, 1. And now because it's a square graph again, I can check it out. Square x squared, it is a parabola. A parabola just means it's a U shape. Doesn't parabola sound like parabole? Bowl, it looks like a bowl there. Okay, so you make sure that you make it a U instead of a V. U instead of a V. And there's that graph. You can double check once again on Desmos. Instead of having absolute value of x now, we have x squared. And then over here we have 2x squared minus 1. Okay, so there's my original parent function, and here's my transformed. I bring it over. Notice how this is a U shape, and we just moved it down 1, right? We started at 0, 0, and we moved it down 1, and we stretched it. It's a little bit skinnier than the original one. Next problem. Okay, so our basic parent function looks like a radical. So I'm going to go get my radical values. Now because of square root, I'm going to pick radical values that are nice, right? Perfect squares. So I know a square root, you can't have negatives inside of the x's because of the domain. So that's why I started with 0 instead of -1 like all the other ones up here. And then 1 is the first perfect square. I'm not going to pick 2 because I don't know what the square root of 2 is. It's not a nice whole number. So that's why I went out to 4. So 0, 1, 4. Plugging it into the square root, you get 0, 1, 2 for the y values. So there's our original table. And then I write 0 because y is equal to the square root of x, 1, 2. Okay, so there's your parent function. Now we're going to write our transformed function. Well, inside with the x looks like an x minus 2. So I go over here, f of x minus h, we're moving to the right. To the right, all these x values are positive, so I have to write a, whoops, blue, x plus 2. Okay, and so I'm going to add 2 to all my x values. So 2, 3, and 6. Now the y's, I don't see any y values. There's a 1 out here and there's a 0 back here. There's nothing we're doing to the y's, so the y's get to stay the same. The y's are staying 0, 1, 2. We're just moving every point to the right 2 units. So now these are the ordered pairs I'm going to plot. 0, 2, 0, 3, 1. And 6, which is out here a little, let me erase that. 6 would be like right here, comma 2 is up here. Now look back at the basic shape of a square root function. We're dealing with this bottom one. It looks like the square root itself, right? If this is the tip and it's going out that way, that's the basic shape. If remember, we're looking sideways right now. So then I go back here and we're going to start at 2 and then connect it, and it does go on in that direction forever. And there you go. Next one, the cube root, the third power is called cubic function, a cubic function. So I see that exponent to be a 3. So my original parent graph will be y equals x to the third. Go to your table. It's on the next page. The cubic, right, x to the third. Here's your table, and this is what it looks like. Okay, that's what it looks like. So then I come back here and I plug in -1, 0, 0, 1, 1. This has 3 transformations going on. Can you name them? I love it when you talk to the computer, right? Yes, that's awesome. It's going to have a shift to the left 3. It's going to have a flip over the x-axis, and it's going to have a push down 1 unit. So those are the 3 transformations that we have to put into the new table of values. So x plus 3, remember plus inside with the x, plus inside the x moves to the left, and the left is negative. So I'm going to put an x minus 3, and all of my x values I'm adding a -3. I don't have enough room over on this side, so -3, so that's why I put a -3 plus. It's the same thing. -3 minus 1 is a -4, -3, and -2. So now the y's have the green and the blue, okay? Green and blue. Order of operation says you have to multiply the y's first and then subtract 1. So this is going to be a flip over the x-axis, and this is a push down 1. So -1 times our y, and then -1. The negative comes first, so I'm going to multiply by -1. And then I'm going to subtract 1. Okay, so negative times negative is positive, so 1 minus 1 makes 0. 0 times negative 1 is 0, minus 1 is a negative 1. Negative 1 minus 1 is a negative 2. So we graph negative 4, comma 0. We graph negative 3, negative 1. And we graph negative 2, negative 2. Now don't make a straight line there because those points are coming up in a straight line. Not true. Remember, this is an x to the third graph, and x to the third has this little curve to it. It's like a parabola, right? But one side's pointing down, one side's pointing up, and it has a curve to it. So be careful. We flipped this graph over the x-axis, so that's why this side is now going to be pointing down and this side's going to be pointing up in our graph. So we have, where'd my pointer go? This side coming down here, and then we have some curve pointing the other direction. Okay, so we do have curve to this side and curve to that side. Now this is one that you might want to check on Desmos. That instead of a square, we have a 3. And then this guy, what was it again? Hi! Alright, so I plugged in the parent function, I plugged in the transformed function, and I look over here. Let's move that down. If you see this point here, that's our vertex, right? That's the middle point. And then you come over here and plot this guy. Let's see if I can. There we go. Ooh, why isn't it going? Stay. Okay, but you see the negative 3, negative 1. So from 0, 0, I moved it 3 to the left and I moved it 1 down. And then instead of going up this way first, because we had that negative in front, it now makes that side move down. And then this side moves up. Okay, so you can see that this is the final graph. This was the beginning graph. The exponents change the shape of the graph, right? X squared, x third, x to the fourth. So that's where the table of values is going to come in handy to know what are we actually talking about here. Next one. So for these guys, we don't have a parent function, right? We have this random function here. So f of x are these points. I put 4 points really, really clear so we can make our own table of values. You can't use the chart because this isn't one of the parent functions. It's just a made-up one. So this is my x and this is my y. And this dot right here looks like it's negative 3 up to 1, 2, 3. This point right here is 0, 1, and then 1, 3. So I'm making my own table of values, and this one's going to be 5, 1. And you're going to use this table for every problem on this page. Every problem on this page. If you're more visual and you see f of, right, x minus 2, now the same thing, y is the same as f of x. So anytime you see f of x, it does mean y. So inside with the x is x minus 2. So what am I going to do to all of these x's? Good job, you answered. Yay! You're like me, we're talking to the computer screen. Yes, we are going to be moving to the right 2 units. So all of my x's, I'm going to add 2. So 2 plus negative 3 is negative 1. 0 plus 2 is 2. 1 plus 2 is 3. And 5 plus 2 is 7. Now, if I look on the outside of f, there's a 1 there. If I look in the back of f, right, there's a 0 there. That means we're not doing anything to my f. I'm not doing anything to my y. So the y's stay the same as what we started with. 2, 1, 3, 1. And then you plot these points. Negative 1 up 2, 2, 1, 3, 3, and 7, 1. Ooh. Ooh. Oh, why is this not working? There we go. Push too hard. So then it's going to have the same shape as this little checkmark-ish type of figure. And I have my answer. That this point right here, we moved over 2 units, and that's where that point came from. This point moved over 2 units, and that's where this point came from. So that's why I was saying if you don't like the table, you can just physically see and move the points around. That's going to be perfectly fine. The next one. Okay, we need our table of values from above. Okay, and now we have a x plus 1 inside with the x. Inside with the x means we do the opposite operation. So instead of adding 2 like we did up here, we're now subtracting 1 because it's x plus 1. The opposite of plus is minus. And now we do have something on the outside. That outside is minus 2. That minus 2 is going to affect the y, so I'm going to subtract 2 to all the y's. So I go back to my original table, this red one up here, and we're going to take the negative 3 and minus a 1. We're going to take the 0 minus 1, take the 1 minus 1, take the 5 minus 1. Notice these are the numbers I just said, and I'm going to subtract 1 to all of them. So I get a negative 4, negative 1, 0, and 4. And then we do the same thing again. We take our original y's and we're subtracting 2. So 2 minus 2, 1 minus 2, 3 minus 2, and 1 minus 2. So I get 0, I get negative 1, I get 1, and I get negative 1. So now I did that on purpose so I can see my ordered pairs that I have to graph. So negative 4, comma 0, negative 1, negative 1, 0, 1, and 4, negative 1. Is it the same shape as what we did originally? Looks good to me. Okay, it's that little check mark going on. It's just we moved 1 to the left and down 2. Let's see what happens here. Inside with the x, I don't see any plus or minus. Inside with the x, that means there's nothing being switched to left or right, so my x's get to stay the same. Yay! But on the outside, I see a negative 1, and I see a positive 1. The negative 1 flips the whole graph over the x-axis. So we're changing all of our y's. Instead of being positive, we're flipping it to be negative. Or if they're already negative, we're flipping it back to be positive again. So we're changing all our y values, and then we're adding 1 to it because of that back. We're moving the whole graph up. So I have negative y plus 1. We do multiply first by negative 1, and then we add 1. So 2 times negative 1 is negative 2, plus 1 is negative 1. We multiply by negative 1, and we add 1. So that's going to be negative 1 plus 1 is 0. Multiply by negative 1, and we add 1. So that's negative 3 plus 1 is negative 2. And one more time. That's negative 1 plus 1 is back to 0. So these are the new points that we get to plot. Negative 3, negative 1. 0, 0. 1, negative 2. And 5, comma 0. Now you might say, well, that looks kind of weird, right? It's not the same shape, but it shouldn't be the same shape because didn't we flip it over the x-axis? Then instead of having this corner facing up, we now have this corner facing down. And then we moved everything down 1 on top of that. Okay, so that's perfect. Last one. We have every single transformation going on. We have the inside, x minus 1, is going to mean that we're going to be adding 1 because it's opposite operation to our x's. So x plus 1. And then we have the 1/2 in front. It's like the negative 1 that we talked about. The 1/2 in front is affecting the y. So I'm going to multiply all the y's because it is 1/2 times f, multiplication. And then the last one is going to be that plus 2. It's on the outside, so we are shifting everything up 2. Up 2. So you have to do each of them individually. So I'm going to erase this for the new problem and say we're adding 1 to all our x's. So that's a -3, 1, 2, and a 6. The y's we have to multiply by a half and then add 2. So 2 times a half is 1. 1 plus 2 is 3. 1 times a half is a half, and then add 2 is going to be 2.5. 3 times a half plus 2, that's like 3 halves. 1.5 plus 2 is 3.5. And then we do it again at 1. Since I already did the 1 up top, I'm going to use the 2.5, which is the same. Okay. Once you get all those guys, notice how I don't use the x's to find the y's. I do separately. The x's, you have your own operation, and the y's, you have its own operation. So -3 up 3, there's the first dot. 1, 2.5. 2, oh, that's the wrong side. 1 is on this side, up 2.5 is right there. 2, 3.5, and 6, 2.5. And we get really like smushed fat, right? It is going to be the same basic shape, but it's just not as steep of a slope. It's more of a shallow slope. We had to condense it. It's called a compression because of the 1/2. The 1/2 is less than 1, so that's why it gets super fat. Okay, and that's it. So I would recommend that you do go back over these operations, that you know what's happening to the graphs by any of these moves, and then it should be totally fine from there. Good luck. I'll see you soon.